So this is a much easier one, but let's read it and see.
There are 1,000 boxes in a room. They are all open.
Yes.
Close all the boxes that are multiples of 1.
Yes.
And open all the multiples of 2.
Mm-hmm.
For all the multiples of 3, if the box is open, close it. If it is closed, open.
Okay, stop. So let's do a simple example. Always when I read a problem, if it's a little lot of words, I try to make a simple example. So imagine there are 3 boxes in a room. So first, they are all open, right? So now you close all the multiples of 1. So that means all of them get closed. Then you open all the multiples of 2. So if there are 3 boxes, which one gets opened?
2.
2. Then for all the multiples of 3, if you go to the box number 3, is it open or closed right now? It's closed, right?
No.
If it's closed, you open it. If it's open, you close it. And you keep doing this, right? But there are 1,000 boxes. Of course, in this example, 2's multiple doesn't come. But if 4, let's say there were 4 boxes, box 4, will it be open or will it be closed?
Open.
So you have to go through and figure out this, okay? So now the question is, how many boxes will be open?
Out of 1,000?
Huh?
Out of 1?
Yeah. Hard, right? Seems fairly easy, but it's hard. And of course, what we do is we try to imagine what happens in our head, and we cannot see the pattern, right? It's hard. So one trick which I want to show you today is again same thing. Why can't we make the computer open all these boxes? Then we can see what goes on, right? So how would we do this? So that's our second problem for the day. So first, let's talk about it. Interesting problem. Does anybody know what the answer is? What's the idea here? Can we get any insight on this problem?
It's interesting, but I don't imagine someone actually doing this. So I wonder,
No, what you're going to see, this problem is, by the way, it's given in high school textbooks.
Really?
Okay, and the reason this problem is given is because there's a very interesting pattern here.
Okay.
And the pattern has to do something cool with the properties of numbers, right? It's not to do with boxes, but each box has like the box number 15. Whether 15 is open or closed depends on the property of number 15, right? So that's why it's interesting. No, so these are all good questions, right? Always we must ask the question, is it an interesting problem? Why is it interesting? Just because I put it there, I spend a lot of time trying to see if it will teach us something interesting, right? So I don't just put it there, but you must ask always, just out of affection or respect for me. Don't say, oh, we just put it there, we should not ask the question. You should always ask the question, right? Like, what is this, Vijay? Come on, I'm not opening boxes. What is going on here? But okay.
Vijay, my guess would be like, you take a number, find all the multiples, right? And if number of multiples is even or odd, then
yes. See, Manish, yes, excellent, Manish. That's the correct thing, right? Look for some reasoning. Manish came up immediately with a good theory. He says, okay, I will take a number and this box, let's say box number 15. Let's just do it in practical. If I take box number 15, so first, because it's a multiple of 1, it's going to be closed, right?
And it's a multiple of 3 also.
Then it's a multiple of 3. So when 3 comes through, it's going to open it.
Yes.
Then it's a multiple of 5. 5 is going to close it. Then it's a multiple of 15. It's going to open it. Yes? So we can say that the box being open or closed. So because everything is a multiple of 1, it's basically like starting with all of the boxes closed. Yes? So if a box is going to be open, that means it's an odd number of multiples. Yes?
Yes.
If a box is closed, it means it has even number of multiples. It's a multiple of even number of numbers. Okay, this is as much as we can say. So therefore, can anybody, based on what I said, can anybody solve this problem? Which number has even is a even multiples, odd multiples? Can we figure this out? It's very interesting, right? If you know enough about mathematics, you can ask all these questions. What kind of numbers have even number of divisors? Multiples means it's divisible by the number, yes? Does everyone agree with my statement?
Yeah.
Like 15 is divisible by 3, 15 is
3.
divisible by 5. Yeah.
I also.
So it does a number. Okay, so let's ask. So those are all interesting questions. Does a number have to have even number of divisors or odd number of divisors? When I first saw this problem, I asked this question. I suddenly realized, oh my goodness, nobody asked me this question in high school. Because we learned how to divide in high school, but we didn't ask this question, right? I don't know. Did any of your teachers ask you this question? No. But it's a very important property. You're going to see, of course, this particular problem highlights it. Later, you can go and see, it's important sometimes to know how many different ways you can divide a number into two pieces, right? And the question is it even or odd or what? Okay, so instead of trying to solve the problem, of course, I can solve it mathematically. Let's just go simulate it. So go to the file now, and it's called simulate boxes, I think, BoxesPuzzle, yes. Okay, so we're going to simulate this BoxesPuzzle. Cassandra, if you go to codeboard and click on the file called BoxesPuzzle. Okay, so we're going to simulate something here. Okay, so the first one is really a big. Okay, so before we write any code, does anybody have an idea? What are we going to do? How do we do this?
For loop?
Yes, that's a good
Okay.
start. I'm missing Kiran. She would have said for loop right away. But yes, okay, for loop, yes. But what now we have to do some idea. So I think it's important, right? I think it's important that we break this problem down. Cassandra, the function at the top, leave it as pass for now. That's the big function to solve the problem. So call it pass. Okay, so let's go here and simulate boxes. That's the function I want to do. Okay, so first let's do. So my idea is the following. You tell me if this is interesting. How do I represent some number of boxes? How do you want to represent these boxes? First, let's start with one box. How many states does a box have?
2.
Okay, so how do you want to represent these two states? You can use the word open and closed. Let's use the word open and closed, yeah? Okay, so how can I store the state of suppose I have n boxes, some are open, some are closed. How can I store this information?
You can make a list.
Huh?
No, someone was speaking. I was going to say make a list of
Yeah,
all the states.
that's it. That's wonderful. Yes. So I'm just showing you how we should think about this, right? First, we should ask how can we represent the states of my problem. In this case, there are 50 or 100 boxes or 1,000 boxes. We put them in a list, and in each index is the index of the box, the ID of the box, and then we will put it open or closed, right? We'll put a string in there, open or closed, okay? So I'll show you now something very cool programmatically. Suppose I want to create, suppose number of boxes is 100. How do you create a list of 100 boxes? And I want all of them to be open. I only create a list of 100 open boxes. Vanshika.
Maybe we can use 1 for all the open boxes and 0 for all the closed ones.
Yeah,
and then we can store them all in the list. Like if they are all open at the beginning, then we have to store 100 ones in a list. Maybe.
Yes. Sorry, I didn't know Kiran was here, so because I couldn't see on the screen, I guess. Yes, Kiran, what were you saying? Can you say, is your microphone on or no?
She was chatting.
My microphone is working.
Okay. So speak. Sorry, I couldn't see your name on the list, but now I see it. Yeah. So what were you saying, Kiran? You texted something. So we say it off in words, no?
Yeah, actually, I was texting Siddharth. He asked some questions. I was answering him.
Okay. Good. Excellent. I love it. But in this case, I know that you're there, so that's good. Okay. So what's the idea? How do I make this?
Yeah. So Vijay, what I was thinking was that we can assign number 0 or 1 two
Yeah,
open
yeah.
and two
So
boxes?
I want to be luxurious. I want to use a whole string. I want to say open and close. So like I can.
Okay, so you can.
Okay,
so you
but
can
it
make
doesn't matter.
lines.
My question is valid for 0 and 1 also. So how do I create a list of
Yeah,
length
right.
1000 and set all the values to 0 and 1 or open or closed? How do I do
I
this?
think you can start with closed boxes, because in the first
Yeah?
statement itself, you have given that all the boxes with multiples of 1 should be closed.
Yeah, you can or you can close it. Doesn't matter. Yes, but doesn't matter whether it's open or closed. How do I make a list with 1000 values in it?
I would have thought you run through the process, and every time you get a value, you add it to the list.
No, but how do I get the starting value?
Oh, for them all to be
All
open.
to be
Sorry.
open.
For I in range 1 to 1000.
So that's why I said Kiran would say for loop. Okay, so I'm going to show. It's Kiran, I'm picking on you, but I hope you don't mind. I'm just
No,
going to.
I don't mind.
No, I love the fact that you come up with a for loop right away. That's a great thing, right? But here, my goal is to show you that there are sometimes a better and more compact ways to do it. So I'm going to show you this, Cassandra. So you say, let's call this list boxes for now. Okay, just boxes. Don't have to say it's a list. We know it's a list. So let's say boxes equals. And now let's create one open box. How will you create one open box, Cassandra, in a list? So put the square bracket. Yeah, inside. If it's open, what do we have to write? Yeah, wonderful. Now I want 100 or 1000. There's a simple operation here. It's the multiplication operation. So if you go outside and do star, and then you put whatever number. Here it should be number of boxes. Yes, we're going to pass in the number of boxes. This will create a list that has, if number of boxes is 10, it has 10 entries called open. If number of boxes is 1000, it has 1000 entries called open. Isn't this nice?
Yep, that's great.
Yeah. Better than a for loop, Kiran?
Yeah, definitely.
Yes, better than a for loop, right? Because this is very compact. That just does my job. Yeah. So again, I want to share with you that these are little programmer tricks. We want to pick them up. We want to use them. First time you see it, you'll be like, why is it multiplying? It doesn't feel natural to me. But later you'll understand these things and start using them. This is my process too. Initially, when I saw it, I'm like, oh, somebody's trying to be clever. I don't want this. So if you don't want this, you can always write a for loop. Okay? But later you might try to say, this is how Python code looks like. This is what Python programmers use. I can also use it effectively. Okay, so we got the boxes. Now what do? We got to go and flip something. So now, Kiran, it's time for the for loop. So what do we do? First, you have to do a for loop over what?
Over the factors of 2.
Yeah.
Sorry, over the factors of 1000, which are divisible
1000 boxes.
by 2.
Wait. So can you just describe the process to me first? You got to, let's say, start with 1, for example. If the current number is 1,
Yep.
then I have to flip all the box multiples of 1, right? Yes or no? Okay, so let's do this way. Cassandra, delete this for loop first.
I think, okay.
Yeah. You ask the question, Cassandra.
About what? Oh, I think, at least I was confused about what we're doing in the.
So VJ, instead of this, we could have gone for closed in 2000.
Yeah, we'll do. But I'll show you. It doesn't matter, Kiran. It's just one more index as far as I'm concerned. So just go back to codeboard. I'll show you, Cassandra. I'll ask the right question. So let us set the current number. Let's call it something. Current number. No, don't do a for yet. No. Delete the for. Okay, current number. So I'm showing you guys how to think about these kind of problems, right? When you have to write complicated things, first do a simple example in your code so that you can actually, you don't have to carry all this weight in our head. So let's say the current number is 1 just now. Later we can change this to 2. Okay, if the current number is 1, what should I do to all the boxes? Now write a for loop. I had a for over the number of boxes, right? I had to go over to each box, yeah. So you can do for I in range. What is the range now?
0 to 1.
0 to
1 to 1000.
99.
Yeah, Kiran says, yeah. So first you have to do range, Cassandra.
I don't remember.
1, 1000.
1 to 1000 it would be, because the number n is 1000. Yes.
Yes. No, but don't put 1000, put number of boxes, yes?
Yeah, yes.
Oh, good. So this looks good. Notice something here. We have to be very careful. We can come back and analyze this. You can start thinking about it already.
But
What is the last index? If suppose number of boxes is 3, what is the last index in number of boxes?
1, comma 2, 3.
No, the last.
Very
The
good.
last
I
huh?
think we're missing a box. Shouldn't it start at 0?
We'll come back and solve this problem later. Okay.
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 Number
But you have to
plus-
pay attention. Okay. This may be like small homeworks for all of you. Okay. These are all important things anyway. Don't do anything right now, Cassandra. We'll come back and fix it. Okay.
Okay.
Maybe we can even print it out so we can see what the hell is going on. Okay. Okay. What are we supposed to do? When are we supposed to flip? Okay. So let's do one small trick here. Suppose I make the current number 2, because 1 means it has to flip everything, right? Doesn't give us a general pattern. So can I say the current number is 2? What am I supposed to do? If I pick a current number, what am I supposed to do?
You're supposed to close it for the first time, Vijay. All the boxes have to be closed for the
No,
first.
that's why I said ignore 1. If the number is 2, what am I supposed to do?
Oh, you only if it is a multiple of 2, then you
Yes. So how do we do that? First you have to check if it's a, but first what has to be a multiple of 2?
The number of box.
The box ID, right? Which is I.
Box number. Yep.
Yeah. Okay.
I equals 2 equals.
Okay. No, I equals 2, no.
Yeah.
So you have to do, yeah. So there are 2 ways of doing this. Can I show you my,
If I is divisible.
yeah, so that's be %2. I %, don't put 2 there, put current number. No, instead of 2, call it current number. Okay, equal to what? That has to be equal to 0. If it's divisible, it will be equal to 0. No. Okay, you can do that way too. Oh, yeah, that's fine, Cassandra. What do you
It's
do?
fine.
Yeah, you can do
Cassandra
it.
is
Yeah, colon. Yeah, now what are we going to do?
Open.
Okay, do we know for sure it's open or closed?
We know for sure it's closed. Oh, no, we don't.
Yeah, for a general number, we don't know if it's currently open or closed, yes?
I guess.
Suppose I give you some box number 53 and I tell you the current number is something. I mean, current number is 15 and the box is 53. Do we know if the box is open or closed? Kiran, what do you think?
Vijay, actually, I have a concern here. I have been pointing out to one thing which I think I'm right.
Yeah.
So basically, the question is that all the boxes in the first go have to be closed.
Yes, but then I'll make current number equals 1 and it will take care of it.
So whatever is the current number, it has to be closed. Since all the boxes in the first step have to be closed.
Yeah, it doesn't matter. Yes, that's true. But now after the second step, only the even boxes will be boxes will be open, right?
Yep. Now the even boxes have to be open.
And then after the third step, some weird things, right? 6 is odd, but divisible by 3 and 2. So the pattern of knowing whether a box is open, if I tell you what is the current number and the box ID, can you decide is the box open or closed? At this point, do we know enough or we don't know?
No, we don't know enough at this point.
Exactly. Does everybody agree with this?
Yes.
Yes, we cannot easily tell, right? I mean, that's half the problem. If you know, give me a current number like 5 and a box ID like 23 and say, is it open right now? That's very hard. So we don't want to deal with this. So I want to write a function, okay? That function is called toggle. And the toggle function, basically, it's going to just take the current state and flip it. Isn't that cool? If we can write such a function, then I don't have to worry, right?
Yeah.
Okay, so good. Delete the past, Cassandra, and how do we write this way? So the state value can either be what? It can either be open or closed. So you can say if it's open, change it to closed, return closed. If it's closed, return open. Yes.
Okay.
If state equals open, if Cassandra, if state double equals open, then what should we return?
Closed.
Yeah. Write that return closed. No, then Cassandra, just return closed. And also you need a colon after the if. Okay, then go down below. And then what? You don't need the bracket there.
Okay. And the opposite, inverse.
Yeah. If it's closed, make it open. See, this is cool, right? Does everybody agree this is a cool idea?
Yes.
Yes, because then we don't have to figure out what to do. Just give it to this function, it will flip it.
But we don't need to set up states.
Actually, we are testing the two conditions right now over here, no?
Yeah, we're testing the two, but we don't know which one is going to show up.
Yes.
This function will take
Obviously.
it. Okay, good. Now I'm going to show off a little bit here. Cassandra, actually, you could probably write it as an if-else statement.
Yep.
Oh, okay.
It would. The second would be a statement.
No,
Yes.
you can. Yeah. No. Control Z. Yeah, that's fine. Yes. Okay. Colon. Else colon. Okay. Does anyone want to see? Okay, maybe I won't. There is a way to write this in one line, but maybe that will make your head hurt. So I won't do this. Is this okay? You guys are comfortable with this, right?
Yes, sir.
Okay, let's leave it like this. I don't want to make the life complicated. So now we can use this. Can you just
Excuse
quickly?
me. I would like to see the other way also.
Okay, just keep the question in your mind. Okay, I will come back and show you. Okay.
Okay.
So Cassandra, what we're going to do quickly is let's test this function now. Let's put a print statement and see.
The cool simulation to write in this tab.
So you just type something. You're going to, if you toggle a box, if you toggle a box with state, put a bracket there, it will become, and then put a bracket there, and then outside the string dot format. Now, what is this? In which file is this located? BP dot toggle. Okay. And just let's pass. What do you want to pass in? Closed or open? Open. Then because we want to show what is it, just put the open in the first. Just go back to the format in the beginning. In the inside the format, we need two parameters there. Just put open. Just put the string open as the first parameter to format. Inside the bracket of format.
Okay.
Yeah, we need two values, right? We have two slots in our string. Open. You have to put the string open. Comma. Does it make sense, Cassandra?
No, I'm sorry. I don't know.
No. You wrote the string, right? If you toggle a box with state, there's a bracket there.
Mm-hmm.
What value should show up in that bracket?
Oh, yes. Okay. Yes.
Yes, Cassandra's happy. Just run it. I hope we didn't leave the other function in a broken state. Yeah.
Oh.
Can we just go back and look at this? Find numbers with odd factor count. I don't know what's going on. Let's just go BoxesPuzzle. Can you scroll down? Oh yeah, there's a problem with our simulate boxes, Cassandra.
Oh.
Just comment it out. Just put a triple quote there. Yeah, and finish it there. Okay, just run it. Excellent, right?
Yeah.
If the box is open, it will become closed. Can we test the other condition? If it's closed, will it become open?
Yes, surely it would be.
Just change it to closed and see what happens in both places. So does everybody see this pattern? We create small bits of functionality and make sure it's solid, okay? That way we can make sure that everything will work when we go further on, okay? So let's go back to BoxesPuzzle. Okay, now we continue. So toggle is ready for us. So can you take off your comments, Cassandra? Let's use toggle. Okay, now what are we gonna do? So to pick up from where we left, can I pause for a second and tell all of you, this is the reason why it's very important. We are learning a lesson here. It's very important not to be interrupted when you're working, right? Because we remember so many things. If I take a phone call right now, I would forget what I am doing, right? Does everybody see this?
Yes.
Yeah, we
Yes.
created a function called toggle. We're halfway through some simulate boxes. If I walk away for 10 minutes, I'm not going to remember where I am. And so it teaches us a very important life lesson. Multitasking is not necessarily good for humans, and it's a huge drain on your productivity. It's better to work in a concentrated mode till you reach a good point and then stop rather than get interrupted. Okay, there's a internet meme now. It's called deep work. Deep work has this ingredient, right? We work in focused bursts of activity. But here you're seeing a very practical example. I didn't leave the room or change my context. It takes me a minute to remember where I left off. Yeah. So it's a very practical demonstration. Okay, where are we, Cassandra? What are we doing now?
Can I just ask? I think I'm the only one that's still stuck, but
Yeah.
I don't want to slow people down.
Nothing slows us.
Okay, so maybe I'm confused about what current number is, because I thought, as of right now, if we follow these steps,
Yes.
then we know that all the boxes are closed, right? You were asking us before whether the box would be open or closed. Could
Yeah,
we know?
it's very easy to say when you're at number 2, right?
Mm-hmm.
But what if you're at number 20? If current number is 50, what 23?
Oh,
what?
right. No, I don't know.
Yes.
Okay.
And of course, it would be very tempting to write this code with current number equals 1. But 1 is a very special case anyway, right? 1, that's what Kiran kept saying. Hey, I could just set all the boxes to closed anyway, right?
So the current number stands for how many times we did.
No, the current number says we are implementing the rule for the third line, let's say. Multiples of 3. Look at that line.
Yes. Okay.
So how do I process this? I'm trying to say,
Right.
if I can process it for 3, then I can set it to 1 or 2 or 15. It will work, right?
Okay.
Does it make sense? You just
Oh, so you're saying, I see. So you're saying that when you do multiples of 4, you do the same thing. Multiples of 5, you do the same thing. Oh, okay. I hadn't understood.
Yeah. So right now we put it to 2. If you want, put 3. Pick your favorite number. Doesn't matter. But pick 2 or 3, a small number.
Yeah.
So is 2 good enough, or you want 3?
3.
3 is fine. Yeah. Is current number a good name for the variable? Is it clear? That's fine, right? It's a current number in processing. Does everybody follow what Cassandra asked, and is it clear to all of you what we're doing?
Yes.
Yes. So we're just trying to say, okay, I don't know the whole story, but at least let me figure out what happens for a particular. I have to do this step many times for each number, but let me pick one number and see what the hell it does. If the boxes are in some state, can I process correctly, right? So let's go and process it. Let's see what happens. Okay. So what am I supposed to do? If the current, so I is the box number, right? So let me do one more small thing for you, Cassandra. You can copy that multiples of 3 if you want and paste it down there if you want to, so you don't have to flip back and forth.
Okay. No, I think I got it.
Yeah. So let me just give you a clue here. Instead of calling it I, let's call it box ID or something.
Oh. Okay.
That's easier for us to understand. See, notice all these things will help us. Take off the I in the range also. The I in the range has to be box ID. Does it make sense now? It's easier for us?
Yes.
Yes.
Yeah. So notice all these small things will make us make less mistakes and see better when we look at the code. Okay, box ID is divisible by current number. What are we supposed to do? So for example, if the box ID is 3 and the number is 6, current number is 6. Sorry, if current number is 6 and if current number is 3 and box ID is 6, what should happen?
It's an even number and some
Not
multiple
even.
of 2.
No, not even. We have to say, is it divisible or not? Yes?
Yes, it is. It
If
is.
it is divisible, toggle.
Toggle. So call toggle.
Toggle.
So here you just said toggle.
Okay.
Here you said toggle. No then, Cassandra? Cassandra likes the logical then, but there's no then.
Okay.
Toggle, and then what you have to pass to toggle?
The box ID.
No.
Box.
No. Yeah, you have to pass what? What should we give to toggle? Look at the toggle function definition. What does toggle want?
State. Yeah.
No, but there's nothing called state here. How do I get the state of the current box?
I think we should pass boxes of I. I mean, boxes and square brackets I.
Not I, but box ID. Correct. So Cassandra, boxes,
Yeah, box ID. Okay.
you put a square bracket. We're going to put box ID in there. So basically, we're going to go to the list and we're going to pull out its current state. Does that make sense to everybody?
Yep.
This will return either open or close depending on what's currently stored at that location in the list. Yes? Everybody agree or no?
Yes.
Okay. So now we did it. It's toggled. Once I toggled it, what am I supposed to do? It just returns a value. I have to put it back into the list. Yes. So Cassandra, on the left-hand side of the toggle,
Box ID is equal to.
boxes box ID. Whatever's inside the bracket.
Okay.
Cassandra, it's easy for you to copy. Don't type it. Take it from inside the toggle. Whatever that whole thing is there inside the toggle. No, below, right there. Boxes bracket box ID. That take the whole thing and put it in the left-hand side and put equals. And now let's read it and see if it makes sense. Who's going to explain this?
Okay.
Cassandra already said okay. Why is it okay, Cassandra?
So you're pulling out
Yes.
what it says in that particular place in the list,
Yes.
and you're changing it. You're reassigning it the opposite.
Wonderful. Everybody see this?
Yeah.
But look how beautiful that code is, right? These kind of things make everything so nice. See, there's no, because I moved all the logic into the toggle function, this code looks very clean, right?
Yeah.
Does everybody see? Easy to read and understand what's happening, right? Exactly the explanation that Cassandra gave. So I want you all to go in both directions. One, when you read it, you should be able to understand it. Two, when you write it, your mind should be thinking like this. I have to update the current box ID, so I'm going to pull it out. Then I need some kind of toggle function to switch the state, and then I'm going to assign it back. And then the code gets written automatically for you if you think like this. I said something very profound, but is everyone able to think like this yet, or we are working on it? Kiran?
No, Vijay, I'm not working separately on this. I'm just looking
No.
at
I'm saying, is your mind already working like this, or your mind is getting to work like this, learning to work like this?
Vijay, it's partly I'm learning and partly I could have written some of these things.
Yes. And you see the gap, right? I mean, all of us could, if we push and put you in a room and lock you up and you spend a lot of time, you will end up hopefully with some kind of code that works.
Yeah.
Here I'm saying that code should not only work, but it should also have a certain flow. And that flow is representing your thinking also. So I'm trying to change how we think about the problem too.
I'm learning to think like this only when you're with us and you can guide us.
It'll come. I promise you it'll come. Right? But you see, that is a little secret ingredient, right? And I'm saying that it's hard for me to teach, but only by showing and reflecting on this process, you guys are going to pick it up, right? I don't want to just give you some code and you're just doing something. Really, how do I think like this? How do I change my thinking so that it gets organized like this? That's important. So I just call your attention to it. Okay, so now let's continue. So are we done?
Not yet.
No.
Okay, so can I, okay, let's do return boxes for now. It should be outside the for loop, Cassandra.
Oh.
Okay, so now let's ask the question. If suppose I said number of boxes equals, say 6, for example, and I ran this, we can see what happens, right? We can test it, right? So Cassandra, can you just copy the function name and the parameter on top, simulate boxes? Yeah, copy that whole thing. Let's go to main and write a small test. By the way, we should technically put all this in the test file, okay? I'm being a little bit not clean here. Just print it out, Cassandra. Don't even write anything.
Okay.
Just do BP dot simulate box. You have to do BP. And what is the number of boxes you want to simulate? Let's do 6 or 7. Okay, before you run it.
With only 6 boxes?
Yeah. Which should be open, which should be closed? Go to the function, read the code, and tell me which should be open, which should be closed. No. We are not solved the problem yet. Whatever code we have written, what is it going to do?
Oh, only for that step. Okay.
Yeah. Just look at your code. Go back to the simulate boxes thing. Boxes puzzles.
If it's a multiple. Oops.
No, boxes puzzle. Sorry, first one.
If it's a multiple of 6, you're gonna do the opposite.
Wait. Is it multiple of 6 or what? The number of boxes is 6.
Oh, the current number is 3.
Yeah. So now tell me, if 6 boxes come into this, if the 6 number comes in here, what will be returned from this function? Can somebody figure it out and tell me what will happen?
I think I can.
Okay, slowly, let's do it.
It will be closed.
Which one will be closed?
Number 6 will be.
I didn't ask about number 6. I asked about the whole list.
The list is gonna have open, open, close, open, open, close.
Okay, some kind of close. Okay, so now, okay, anyone want to try again? Cassandra?
3. Yeah, Vijay, I think 3 and 6 should get closed.
Okay.
And the rest should remain open.
Okay. Vanshika, what about you?
I think the same too.
Okay. Run it. That's why we run it.
Okay.
Okay, now let's reason about this.
Oh, because of the index.
Yes.
Okay.
Does everybody see this now? The lists always start with 0, yes?
That's one.
No, this is fine. I think num boxes is fine, Cassandra.
Okay. Did I run it again and see?
No, it's fine, but it confuses you, right?
Oh, that's
It's 0. Starts with 0.
oh.
Starts with 0. Okay, so we can leave the 0th box if you want. You don't have to worry about it. But you have to remember later when you make some conclusions, right? So which box is actually open? It's the 4th index, but it's actually the box ID 3, yes?
Yep.
Does everybody see this?
Yep.
It's a little confusing, right?
Wait,
So if
so
you want
this,
I think it should be, yeah, I think it should be range 1 to num boxes plus 1.
That's what Cassandra was trying to do.
oh, I don't know what
No. Range 1 won't help. The list will always have a 0 index. So
Okay.
you have to do num boxes plus 1 though, if you want to see the 6th location. So this is a possible strategy. By the way, there are many strategies possible here. Oops.
Uh-oh.
Yeah. Index out of range. What do we do? For box set. Yeah. That's.
1.
So, no. 1 second, Cassandra. You have to also make the number of boxes in the top line, first line. You have to make one extra box. Right there. Num boxes plus 1 there also. No. Oops. Yeah, just do num boxes plus 1. No.
No, in the boxes.
There.
Equal to.
You have to have one more slot in your list. Plus 1. And just put a bracket just to be sure. By the way, the bracket is needed, yes? Multiplication is higher precedence.
Is that still wrong?
Why is it wrong?
Well,
Because, okay, so now let's do a thing here. The box IDs are starting from 0. So the first slot has a box ID of 0. Yes? Cassandra?
yes.
The second slot has a box ID of 1. Then the next one, box ID of 2.
Oh. Okay.
Okay, this is one of those challenges by working. Lists always have to start from 0. If you're using a list, you cannot make it start from 1, yes?
Okay. So we have 7.
But what you have is you can choose your counter to go from 1. Yes? Your box IDs, you can say box IDs will go from 1. Everywhere you use box IDs, you can use. No, you don't have to do anything there.
Okay.
If you want
In the range.
in the range, instead of 0, you start from 1.
Oh.
You say, I will never look at box. I will never look at box ID 0. Is that okay?
Yeah. Yeah.
That's okay, right? So hit run. Okay, very good. Everyone sees this pattern now? Something you see?
But
Yes.
it's still printing 7 of them.
It will, Cassandra. If you want to print, then okay, I'll show you how to do that also. Go to
I don't
return.
want to see that.
I will fix it for you. Return
Okay.
boxes. Go to return boxes. 1 sec. And put a bracket. And now we're going to use, put a bracket, and now we're going to use a slice. But this will just confuse you. I think you should always get used to deleting. I can always say 1 colon. Do 1 colon if that makes it better. Hit run.
That's nice.
Is that better?
Yeah.
Yep.
Okay, I don't know. We can we can discuss this later. Okay. So if you
Yeah,
don't want,
we did just a minute. So we could have also done box 0 dot remove, something like that.
no, but then it will just, yeah, you could, yes. You
Or boxes dot remove 0, something like that.
that's fine. Yes, we have to think about whether it shortens the list or not. But yes, correct. You can do it. This is kind of easy to do. Why do I have to modify the list? I just need a subset. I'll just return the subset. That's fine. There's a detailed performance and various discussion here. Doesn't matter. Whatever works for you. Okay. Remember, remove is a tricky one. Are you going to remove by value or you're going to remove by location?
Remove by location.
Remove by location is not remove function. I think it's called del. So anyway, let's not get sidetracked into removing this thing. I personally wouldn't remove anything. I would return the whole list and just get used to not reading the first entry. But we'll come back to that. This works for now. Can we go on? Because there's much to consider here.
Yep.
Yes? Everybody ready to go forward?
Yes.
You find your favorite way to remove this thing if you want, okay? And I'm going to later argue that you don't remove it at all. But anyway, is everybody ready to go on? Cassandra, ready to move forward?
Yes.
Okay,
Yes,
so what do we have to do now?
Well, we have to do this up to the number 50.
Okay, so how do we do this for multiple numbers? You need another, what kind of construction do we need here?
Start with 1.
No. Who's going to change all these numbers?
A bigger loop.
Yeah, make a loop. So write a for loop there. So don't delete the current now. Yeah, for current number, for current number in range what?
1 to 50.
No, there's no 50 in this game.
How much is it?
What is the number? This problem has no special number called 50, right? So what is the range going to be? Current number can go from what value to what value?
Up to 1000 VJ?
Yeah, but where is 1000? There's no 1000 or 50 or anything in this problem, right? What's the range?
Oh, okay.
Num boxes.
Yeah, there you go. Num boxes.
Number?
Num boxes, right?
Oh.
Does that make sense, Cassandra?
Okay.
So what is there's a number here called 1000, right? Sorry, I made a mistake. Continue this process until you reach 50.
Yeah, it is up to 50. Yeah.
Oops, there's a typo in my thing. That should be 1000. I first did it for 50.
Oh, that's why I thought, okay.
Yes, my mistake. It should be 1000.
Okay.
Okay,
I
but
thought
that...
it was 2000. Okay.
My mistake. I'm so sorry.
Okay.
Okay. So num boxes. Is it num boxes? Num boxes plus 1? What is it?
Plus 1?
It should be plus 1.
Okay, let's try it and see what happens. Okay. Okay. Cassandra, each time you change the current number, you have to do the whole thing. So indent it. Yeah, and remove the blank line here. Are we done? Return boxes should be outside. Okay, are we done?
Yeah.
Okay, try running it. Let's see what happens. Okay, something happened. But it's interesting. Not all boxes are open at least right now. Can we make it up to 10 and see what happens?
Sure.
Okay, some of them are closed and some are open. Okay, so now one question would be interesting. Wouldn't it be nice just to know what is the idea of the boxes that are open? Or you're going to sit there and count every time?
No, it would be great to have the ID along with it.
Yes, so how do we get the ID?
So
go
we
back
have to return the ID also, and then in the print statement in the main function, we can print out the ID.
Okay, so let's go to BoxesPuzzle. Let me suggest something and you tell me. Suppose I just find out a list of all the open box IDs and then just return that. Is that enough? It's enough, right?
There's 1 and 9.
Just 1 and 9?
Oh, 1, 4, and 9.
Okay, so we just now said we're never going to look at the first entry. And our box IDs always start from 1. So now tell me the number again.
Oh, but I thought we took out the first one already.
No, we took it out only when coming out. So we have to adjust all this carefully.
5, 7, 8.
Okay, so let's go back and do this in our heads. I'm saying that okay, I don't know what I'm saying.
Vijay actually removed the zeroth one from the list, the zeroth ID from the box list.
Yeah.
Yes.
So that's no more a problem. That's kind of out of our list already.
Yes. So what I'm saying to all of you is,
4.
let's do a simple example with 3 boxes, okay?
Okay.
What is the state of the first box? Just think about, do 3. Okay, hit run. Okay, something comes out here, right? But do 3 in your head. What happens to the first box? What is the state of the first box if we did this? I'm trying to check if we got the right code. What is the state of the first box?
It should be,
Go back to your code.
well,
Yeah. So it starts, everything is open.
close.
Then the current number becomes 1. 1 is divisible by 1. So
you
it should be
close.
toggled, right?
Yeah.
Okay.
Then multiples of 2, close.
So first of all, right now, let's reason about the first and second locations first.
So something's wrong.
Okay, so how do we fix it? So Kiran, you're in charge of fixing this.
I'm not in touch.
Or Vanshika, who wants to be the project manager? Fix this. Code is not working. We have to ship it now. Customers are waiting. Is everyone thinking or what?
Yes, I'm thinking.
Okay.
So I think we can skip the number 1.
Okay. So you can change, all of you can work on changing this code so that it makes sense to you and it does the right thing.
So for current number in range, 1 should be skipped, Cassandra. It should start from 2.
Okay, so Kiran really wants this. So if you want to start from 2, what does that mean, Kiran?
That means that 1 is open and 1 will not be, number 1 will not be flipped or toggled again.
No, but let's go back to the problem statement.
So the problem statement says, Vijay, that
Close, if it's open, close all boxes that are multiples of 1, yes?
okay, let's go back to the code.
Yeah, go to the code. Is our code closing all boxes?
Yes, so box is equal to close into num boxes and 1 should be skipped after that.
So yeah, Kiran always wanted this. She wanted to start by all the boxes closed. That's what you want, right, Kiran?
Yeah, Vijay.
No. Okay, sorry. Yeah, tell.
So basically, if so, since one is a device, one can divide all the numbers. I mean, it's a perfect divisor. So I think you should skip one, otherwise it will create problems later.
No, but then the boxes should all be closed, right?
So it should be closed. So that's why I said boxes is equal to
I
close and
understand.
number.
I heard it first time you said it. All I'm saying to you is these are equivalent statements. Either you can start with open and start the range from 1, or you can start with closed and start the range from 2. It should not change anything. They are equivalent, yes?
Okay.
Everybody see this?
Yeah, I changed my mind. I think the result is correct, so I'm very
Okay. So then why did you change this now? Okay, so you can run it and see, right? Run this and see, since Kiran suggested it. We'll just remember the answer.
That's the
Same
same.
thing. Yeah, it's the same thing. Okay, so why is this result correct, Cassandra?
Well, I just did it on paper, and if you first close all of them,
Yes?
they're all closed.
Yes.
And then the multiple of 2 box, you open it.
No, before you go to 2, you have to talk about 1.
Well, that's how oh, well, they started open, so I closed all of them.
So that's not, yeah, that's fine, but you have to ignore the first index right now, right, in your output?
Yeah.
Do you understand what I'm saying? The 0th location should be ignored, yes?
Yeah.
Okay, fine. So then you opened all of them. Then?
Oh, I opened all of them?
No, I don't know. You just, sorry, do the following if you can. How can we do this? Just above this code, Cassandra, just above this code, make a list. Just draw a list of 3 elements. I'm just doing all this carefully and painfully to show you how do we do this, right, when I'm not in the room. Yeah, open, open, open. So you see how we simulate this by hand. Okay, now closed. Why is the first one closed, Cassandra? Wait. First of all, can you give me the IDs? What are the IDs?
1.
Wait. Okay. Don't write it there. Write it on top of it. But that's not the IDs on the list, right, Cassandra? It's 0, 1, 2, 3, right?
Oh, but I was ignoring that. Okay.
Well, you can ignore it, but then your program won't work, right? Yes.
I don't know. I wasn't thinking.
No. But was the first one get closed or opened? What happens to the 0th one?
I guess that's
Is 0 divisible by 1?
Yes.
I don't know. I don't even know what Python does if I divide 0 by 1. But okay, if I do modulus of 0 by 1, I don't know what it gives. But anyway, we don't care about that, right? Whatever it is, ignore it. Okay, then?
And then the first one is not divisible by 2.
Mm-hmm.
So it stays the same. This one is not.
Mm-hmm.
And then we do multiples of 3.
Mm-hmm.
So we have, this is not divisible by 3, stays the same. This stays the same, and this one changes.
Okay, good.
So that's.
So then our code is not exactly doing this, right? Or
No,
is
it is. It is.
Well, okay, so you should add one more location to it. Num boxes. Take off. That's why I said take off the colon. I'll tell you what was confusing. Wait. At the end. Just take off that. Return the whole thing. No. Yeah. Just hit run. Yeah. Beautiful. Hit run. Okay. Does it look like what you did?
Yeah.
Yeah. Good. So you understand why putting that colon and truncating by hand can confuse you, yeah? Yes or no?
Yes.
Yes. Okay, so now do you want to do one more number? Can we add one more to your manual?
5.
Can you do 4 as well? No, you're going to do it by hand, so just add one more. Wait, Cassandra. Just do 1, 2, 3, 4. Put comma 4 in the first line. Okay, and then what happens there? That's open.
Start open.
Mm-hmm.
Then we close that one too.
Yeah.
Then multiples of 2, so it becomes open.
Uh-huh.
And then multiples of 3 stays the same.
Uh-huh. Yes, and the last line, we have to do 4 also, no?
And then multiples of 4 stays the same. 2.
Open.
Same. Okay.
See, when
3.
you're working with a current number that's high, the ones below it are not affected. Okay, so we got some pattern. Can we try this? Can we increase by 1 and print it out and see what happens? Wow, that's pretty cool. So it's matching what we did by hand. So wait, can I pause now and can we take a life lesson here? Sometimes working on paper or typing out like this and making examples really helps us, right? We cannot always see the structure well if we don't do this. And being patient and doing this, if you get stuck, this is the way to get unstuck. I have to tell all of you, there are many times in my life when I'm alone trying to solve a problem. This is the only way I can help myself, yes? Getting frustrated, leaving the room. Well, these are probably not the best ways to solve this problem, right? Does everyone agree?
Yep.
Do you see how this simple activity of just calming yourself down and just going and saying, okay, I'm going to do it and see what happened. And I thought I could write the program to do it, but my program is not coming easy. All these indexes and various things are confusing me. So I will just write it out like Cassandra started writing on paper or in the screen here so we can all see it. Now that we have seen it clearly, we match our program to this. Now we feel much more confident that the program is doing the right thing, yes? Does anyone feel that they could not have got unstuck? If they had this problem, would you have taken this path? Or something like this?
Yes, Vijay.
Yeah, definitely.
Yes, I don't want any of you to give up, okay, and say, oh, I'm not smart, I'm not clever, it's too hard, it's too easy, nothing like this. Is everyone on board with me there? Cassandra as well?
Yes.
Yes. Siddharth? I don't know if Siddharth is still there, but yes. Okay, but all of you see this, right? Are we ready to go forward now? Okay.
Yeah.
So now what happens? Let's put 10 and see what happens. Okay, so it seems like we have some interesting pattern here. Some of them are closed and some of them are open, yes? So what we are looking for is which ones are closed. But right now you have to go and count all these indices, right? I think it looks like 1, 4, and 9 are closed. Yes?
Yeah.
Can somebody count and check? Okay, but instead of doing it in our head, can we write a little piece of code to check this? So let's go back, Cassandra. Instead of returning the whole list, let's only list the IDs of those boxes that are open. Does everybody agree that will be helpful?
Yeah.
Yep.
Yes. So before the return, above return, let's write a little piece of code. So let's do for. And now I'm going to use my favorite tool. I'm going to do enumerate boxes. So enumerate boxes will return the ID and the value. Yeah. Enumerate bracket boxes. Okay. And I put a colon. Outside. Okay. This will return 2 values. So let's call them something. ID, box ID, and box value. No, in the left hand side, after the for, I have to catch the values coming out of enumerate. So Cassandra, go to the for, go to the for ID, box ID, comma, box value. So enumerate is different from the usual thing because it will return 2 values. It will return the ID and the content of the box. It will say open or closed. Okay, I got both of them. Now I want to store the IDs of those boxes that are closed. So let closed or open? Closed. So let's create a list called closed box IDs above the outside the for. Before the for. Sorry, Cassandra. Before the for. In the previous line. Yeah. Let's call it, we are going to store all the closed box IDs. So let's call it closed box IDs. And it's a blank list right now, right? So now each time, so now inside this for, put an if statement. If the box is closed, just add the ID to this list. So what are we going to check? Is it ID or what? Cassandra?
Value.
Value. Box value equal to double equals closed. Then what should a colon? What should I do? Just append it. Closed box ID. Dot. No. Plus equals append. I don't even remember. Yeah, plus. No, don't do it like that, Cassandra. Maybe just do. Okay, you want to do plus equals. I'll show you how to do. Do plus equals. But now you have to append a list. You have to put a square bracket. And then you have to put the ID inside it. Box ID. Does everybody understand this?
I have a question. Why can't we use append? I mean, we're just adding the IDs. That's a number.
Correct. Append is nicer for me also, but Cassandra went for plus equals, so that's why you just went with it.
Okay.
You can also do append right here, Cassandra. You can do close box ID dot append. Dot append though. Yeah, no space. And then it's append is a function, so it has to be the parenthesis. No need bracket anymore. We don't need a list, just a number. Yeah. Okay, and then return. Let's return this closed box ID. We don't return boxes anymore. Where the return statement is, Cassandra, delete. That's it. We're done. So now just return closed box IDs though. Careful. The name. Yeah. Yeah. Run it. Let's see what happens. Whoops. What happened there? Let me see. Invalid syntax. What happened here?
Line 33.
There's an in which you're missing. For box ID, box value in.
Oh, yes. I was
In.
okay.
That's it. Okay, 0149. Okay, can we do it up to 50 or 100 and see what happens? Does anybody see a pattern here?
Squares are there.
Squares. Yeah.
Okay, so we know these are all perfect square numbers, right? 2 squared, 3 squared, 4 squared, 5 squared. So now we have to ask an important question. So do you, okay, let's pause for a minute before we understand this. Do you guys see how beautiful this idea was, that we can actually write some code so we can see a pattern? What do you think, Kiran? What do you think about this process?
This is some way of finding squares.
No, I know. I'm not saying that. I'm saying the strategy we used to solve this problem, to make the computer do the work, and then we can see the pattern, right?
Yeah.
Otherwise, if you sat there with a piece of paper, it's hard to see this pattern because you have to do at least 50 boxes or 20 boxes or something to see what's going on, right?
Absolutely. So there was a little guess, there was a little hint when we saw 0149.
But 04, yeah. But you want to be sure, right?
Yeah.
Yes. What about Vanshika? What do you think?
Yeah, I think it's quite amazing. I mean, I didn't expect the squares to come up at all. I never thought that it would be all squares.
Yes. Cassandra, what about you?
Yeah, I had no guess until right now. So.
Okay, so now I'm going to say to you, because of the interest of time, I'm going to actually give you the answer. Okay, really, what we should do after we see a pattern like this first is we must go and ask, why is this true? Right? Why are the squares behaving like this? So I'm going to give you the answer. This is basically, I'm sharing what I did by thinking for 10 minutes about this. The answer is that if you take any number, that number gets affected if that number is a multiple of some number, right? Suppose I take a number 10. 10 is affected by 1, 2, 5, and 10, yes? Does everybody see this?
Yeah.
When the current number, if I pick a number 10, box ID 10, when the current number is 1, 2, 5 and 10, this box will toggle. Does everybody see this?
Yes.
I heard only one yes. Kiran?
Yes.
Cassandra?
Yes. Yeah.
Yeah. So the question is, if a number has even numbers like this. So for 10, how many guys were affecting it? 4, right?
Yeah.
If there are even number like that, if it starts with being closed, what did we start with? Everything started closed, right? No, everything started open. If it starts open and 4 numbers affected, what will it end up as? If it
The same thing.
It will remain open.
Okay, so all the guys who are affected by even number of factors will remain the same thing, right?
Yes.
So now we have to ask the question, is there some guys with odd number of factors? Because they are the only guys who are going to flip, right? Be open. Be closed.
Yep.
Okay, so how can we have odd factors? Because when you have a factor, like for example, if you take a number 10, it's 2 times 5 is 10, right? So 10 is affected by 2 and 5. So the factors of a number always come in pairs, right?
Right.
So can ever factors be odd? So this is why I said to you, the properties of numbers are very interesting. If you count the factors of a number, it has to always be even. Except when it's a perfect square. Because now when I take the number 9, 9 is affected by 3, but 3 has no pair because it's 3 times 3, yes?
Okay.
Yep.
Yeah.
Can you see it? It comes only one time, right? So it's odd.
Yeah.
Yep.
Yeah, so you see that it was possible for us to find this answer by pure thought. Right? If you just sat there and said odd factors, even factors, how is it possible? But it's still in a corner of the room somewhere hiding, right? It's not easy to see it quickly. Does everybody see that?
Yes.
That it's not easy to find it just quickly. By the way, this problem is given in high school, okay? And it's given with the number 100 boxes or 50 boxes. I don't know what the kids do, but I doubt that any kid is actually doing this properly. Well, maybe the smart one. I don't know. Would you have done this in high school? Would you have figured this out?
Yeah. I don't think that I would ever have been able to think that way in high school. I mean, I obviously didn't think that way.
Yes. I also get frustrated
When I do questions with you, when I solve questions with you, I feel that I'm learning maths, programming, everything together.
Yes. But this is life. You're experiencing life with me. Right? And you're having fun with it, right? These are like toy problems that show us that if we don't run away and we take the challenge and we play with it and we engage with it, it's going to show us some nugget of beauty, right? I mean, it's really cool. We found some pattern right now. I'm going to show you even more. But anyway, I just make one last comment about high school. I feel really sad that the high school people don't give them the number 10. They always give 50 or 100, right? It's too big for anyone to try to do it. Like if you can imagine a kid says, okay, I'll write it on paper and see, but if he tries to write 50 boxes, he will go crazy.
Maybe they do it as a punishment.
Yes. You can give it to your class, Cassandra. If they're being unruly, because okay, everybody. No, but I want to share that one of the skills that we have to do here is, Cassandra, can you click on your BoxesPuzzle page? No, not there. The code itself, the .py file. What Cassandra ended up typing for us on the screen with this small. So the idea is when the box number is 50, 500, 1000, doesn't matter what the original question is. We can create a smaller version of the problem, right? Like 3 or 4. And we can beat it to death. We can do everything with it. And when we play with it, that will make us to write the code that allows us to explore bigger territories. Okay, so now there is one exercise I won't do today. You can do this now mathematically. Instead of doing the simulation as we did, you go back. It's just a tweak. No, stay in the same file, Cassandra, quickly. Stay in the, back to the file. We are not yet done. Go back to the file. So you can do this mathematically. You can ask the question, separate homework assignment for you. Instead of boxes and all this, write a program to find all the numbers it's Cassandra, I can show you this actually. Can you see? Is it there in the page? Yeah. Implement the function. You see that second line there? Second line. Can you read it and all of us make sure we understand this?
This one?
Yeah.
Okay. Implement the function find numbers with odd factor count n, to which returns a list of tuples of all the numbers less than n which have an odd number of factors. The list should contain the tuples number of factors. For example, if n equals 5, should be 1, 1, and 4, 3.
Does everybody understand this question?
Okay.
Yeah, it's right there.
Okay. Oops. Okay.
Okay, but does everybody understand the question?
No, Vijay, not yet.
Okay, so let's click back on it, read it one more time.
Okay.
Or you can read it right here. So it's essentially the same thing, Kiran. I'm now making a number theory, mathematical problem, right? You forget about all the boxes and all that. I'm just saying, can you find all the numbers who have an odd number of factors?
The same as the square.
Huh?
So it's the same as the square.
I know, but you can do it however you want.
Okay.
Okay, if you know the answer, you can just write you can write something to generate the squares, or you can find the factors of the numbers and count how many factors a number has, etc. There's something you can have fun with, yes?
Okay.
Does everybody?
Where is the question? Where is the question? Is it in 5.2.1 lab?
No, it's in 5.1.2.
Okay.
In 5.1, I have put all the questions and the details.
Okay. All right.
Yeah, 5.1.2. That's where all the instructions are, okay? For all the problems for this lab. All the instructions are there. Okay, so now let's come back. Last piece of the puzzle. Code board. Or read it from here, Cassandra. What am I asking?
Implement the function solve boxes puzzle n, which will return the number of closed boxes given the total number of boxes n.
Yes. So who's going to do this now? If I give you n, can you tell me how many boxes will be open? Anyone? Vanshika.
Yeah, I'm thinking maybe we can count the, we can find the length of the list which has the closed box ID. So
Yes,
we'll get the
you can. That's a good way to solve it. But Cassandra, can you run this with 100 quickly? Okay, so I want to know what's the length of this, okay? Can I leave it as a homework assignment or you want the answer? I mean, I want a formula for this in terms of the number 100. If I tell you 100 or 1,000 or 10,000 or million, you should tell me how many squares are there in that range. Can you solve it? Huh?
Yes, we can solve. Yeah.
Okay. Try. If it's too hard, send me email or something. Okay. Don't get scared of it. It turns out to be a very nice formula.
Okay.
Okay. Very nice formula. You don't have to do multiple simulations or anything. You can write a simple function of n. Okay. Everybody got it? Cassandra?
Yeah.
Yeah.
Yeah. Okay. So that's it. We're done with this.